In our next real-world example, we're talking about taking a piece of cardboard that's flat, cutting corners out of it, and then folding up the flaps. So when you think of this problem, I need you to think about like a shoebox without the lid on top of it. So it says Dixie Packaging Company has contracted with another firm to design boxes with a volume of at least 600 cubic inches. Congruent squares are to be cut from the corners of a 20-inch by 25-inch piece of cardboard with the flaps folded up to create an open box. So that's the diagram that you're looking at right now. That's our flat piece of cardboard, and then we're going to cut out the corners and then fold everything up to create the 3D box. What size squares should be cut from the corners of the cardboard? Well, I don't know what size they need to be, but I do know that they need to be the same. So I'm going to cut congruent squares out of each corner here. So they're all going to be congruent squares. Now, originally, this entire side had a length of 20. If I cut out an X length here and an X length here, this is what I'm going to have left over. So if the original part was 20 and I cut out an X on each end, that new dimension is going to be 20 minus 2X. Same thing with this side over here. It was originally 25. I'm going to cut out an X on this end, and I'm going to cut out an X on this end. So that leaves this inside piece with a dimension of 25 minus 2X. Now, when you actually fold this up, so if you thought about folding it up along that, if you folded all the sides up, so you cut your corners out and you fold the sides up, the height of the box is actually going to be the height of one of the corners that we cut out. So volume for a 3D object is length times width times height. So our new dimensions are going to be, there's our height, 25 minus 2x is one of our dimensions, and then 20 minus 2x is our other dimension. So right there is the equation for our volume for our box that we're going to make. Now we're going to actually solve this one graphically. So what I want you to do is go ahead and grab your calculators and go to your y equals button, clear out any equations that are in there, and we're going to enter these two equations right here. So the first equation is just our volume that we just created. The second equation is the volume that we're supposed to have, at least 600 cubic inches. So go ahead, take a second, enter these into your calculator. Pause the video. When I was getting ready to do this, I had to play around with the window quite a bit. The window that helped me would be my X min value. I let that be -5. My X max value, I let that be 15. And I counted by 2s. My Y min, I let that be a -200. And my Y max, I let that be 1,000. And I counted by 100s. So go ahead and enter this in your window, and then let's take a look at it. Okay, so when we graph this, we should get a graph that looks something like this, roughly. Now the question says we want at least 600 cubic inches. Well, the green line represents our 600 cubic inches. So we want everything that's on the green line and above. So what we need to do is figure out where these points are, where our two graphs meet. Go to second trace on your calculators. And then we're going to go down to where it says intersect. And hit enter. When you do that, it takes you back to your original graph. And it says first curve in the left-hand corner. Okay, so what you want to do is you want to move your cursor over to this area over here. So just use your left or right arrow cursor. Get your cursor kind of in the area where the first intersection happens. And then hit enter one time, and then it says second curve. hit enter again, and now it says guess and hit enter. And when you do that, that should kick out the ordered pair for where those guys intersect. I got the point roughly 1.659, 600. Okay, pause the video, go find your other two intersection points. When you're done, play the video. Okay, these are the points I got. 6.159, 600, 14.682, 600, and then the one we found to begin with, 1.659, 200. So the question's asking for at least 600, so technically anything that is above the green line or on the green line should be our solution. Now we need to check though, because this is a real world problem. So what I want to do though is check this right end here. So let's pick a number bigger than 14.682, plug it back in, and see if we can get an answer. So I'm going to pick 15. And I'm going to take 15 and plug it back into our volume equation that we just got. So when you plug 15 right here or right here, it doesn't make any difference, you're going to see that we get 2 times 15, which is 30. This gives me a negative 5 for an answer. Here, 2 times 15 is 30. 20 minus 30 is a negative 10. So these would be the dimensions of our box. Now, when I multiply them together, I still can get a positive value, but the problem is negative 5 and negative 10 represents the lengths and the widths on this box, and I cannot have negative lengths on a real-life box. So that tells me that everything above this 14.682 does not produce real solutions in this real-life example. So the only solutions that are going to work then are the ones between 1.659 and 6.159. Remember, we only need to record the x values. We know the y value has to be at least 600. And we're going to use interval notation. Those guys can be at least 600.